So, before the microservice architecture, there was another architecture which is called monolith architecture. Right. In monolith architecture, it is a relational database that handles and it guarantees the data consistency by asset transaction, right? Asset transactions. Right. In their atomicity, consistency, isolation, and durability, the 4 points are they in order to maintain strong data consistency, it was used and it supports the transaction. Supports the transaction. It supports the transaction, right? And after that, like I have told them, it is different than each other. So in this diagram we will get about it. In what basis I was telling you this, right? So let's take it is payment service and it is order service, right? So in this it is database 1, you can take it is database 2, right, which it is stored. Like it can have the direct communication with this, and this is right and this is wrong, right? It cannot have direct communication with database, but it can have communication with payment service and order services, right? So in this example, like in order management system, we might be services such as stock management or anything you want, payment, order management. Let's assume these are services, right? Design in accordance with this is all designed with the accordance of microservice architecture, not the monolith one, right? Monolith one, I was just tell you, it is a traditional architecture. It was used as a, and modern architecture is microservice architecture currently, right? So right, so payment service, order service, right? In this, the second step is like payment service is responsible for the payment business, right? In order services call the order, right? Order service call the payment services and complete the payment of from the customer's credit card, right? This example is basically telling you that how data consistency problem occur here, right? The number of order could not be sent to the customer, but the payment was received from the customer, right? In this at that point, this cause consistency problem, right? This cause consistency problem. After that, we will talk about the possible solution we can use, right? So the possible solutions, we will see the possible solutions. Possible solutions, right? So the possible solutions will be, first is distributed transaction, and the second will be eventual consistency. We have already talked about this solution. Now we will talk about the distributed transaction, right? Distributed transaction, right? So in distributed transaction, it is basically execute on two or more resource, right? It execute on basically two or more resource, right? Such as you can say, for example, database. It can be of database, or you can say message queries, right? It can be on those basis. In this it ensures that it will provide or ensures data integrity, right? Data integrity is basically data accuracy, how accurate your data is, right? Accuracy or integrity, you can write as accuracy or integrity based upon you, right? And after that, this all is for multiple database that has been distributed. That's why it is called distributed transaction, right? After that, what are the benefit of this? Everything has a benefit and limitations too, right? So first benefit is strong data consistency. Strong data consistency. Our problem was how we will handle the data consistency. It has strong data consistency. There's a first solution of it, right? And the second one we have already discussed. And second is it support asset atomicity, consistency, isolation, and durability transactions, right? And after that, it also have some drawbacks. Okay, first drawback, think what will be it. It is very complex. First of all, very complex, right? And secondly, it has high latency. Okay, it can cause we are talking about drawbacks, right? So it can cause deadlocks, right? Deadlock is basically a condition where system is stuck between where should it go. Like if R1 and this is T1 and this is R2 and T2 and these are connected like this, right? Like you can say like this, like wait, it's a bit wrong. Let me do it this, like it means R1 have transaction T1 have the resource R1, right? And transaction T2 have resource R2, right? But when T2 is asking transaction 1 for resource 1, right? So resource 1 is asked by T2 and T1 is not leaving it and T1 wants resource 2. This can cause a condition of starvation and a possible deadlock. And from getting over the deadlock, you can use some elimination methods and like non-primitive methods, you can say no preemptions, right, etc and etc. Now the question arises, which solution we should use, because we have two solutions. One is your eventual consistency and second is your distributed one, right? So distributed transaction, like, so why we use this two, right? What is the best solution among these two, right, when it is used, right? uh from my end, avoid the distributed transactions, right? Cause if possible, right, if possible, cause it brings more it brings more complexity, right? More complexity than eventual consistency, right? And identify your operation first, that what is your operation, right? What is your operation first, and use strong consistency and type this operation, like you should use distributed will be the best one, or the other one, like we have the other one named as event driven architecture, edc, we named it as edd, like design fault tolerant system, which is basically your hit and miss ratio, right? How much data is accurate, how much fault is occurring, right? So it is all about that. And after that, in conclusion, I will say, that microservice, I will use different pen, uh, microservice architecture has great features, like you can say availability, scalability, and you can say automation, and you can say max efficiency or efficient. You can use this term, effective and efficient, effective and efficient, right? It basically used to manage the it is used to manage the data consistency and your data, right? So thank you.